Hey, hello, can you hear me all? Yes, no would help me. Okay, fine. Yeah. Okay. Just give me 1 second. We'll start in 1 second. Next 1 second. I'm just making sure we are at right thingy. Okay. Thank you everyone. For some reason, this is not like enabling my camera, so there is a technical problem over here. But yeah, let's go ahead with this screen share only this time. I'll try to fix this in our next meet. 1 second, guys. Okay. Yeah. So I'll quickly start over here, and we have already implemented this agent part where we have this particular thingy app.py file. I have modified, by the way. There was one simple defect over here. Somebody in our last connect clearly mentioned that defect as well, understood. So I fixed that defect. So whenever you go and you run this, make sure you are getting the latest code from GitHub repository which we have. So this is the GitHub repository for this particular thingy, and this is updated like this app.file. You can use the latest one. I'll clean up this, and you old and all those stuff will be removed out of it. So yeah, so this is about the code fixing today. Um, we are going to give traces to our agents basically. So here what we are going to do is we are going to start with a very uncomfortable question. 1 second. Uh, yeah. So today we are going to start with very uncomfortable question, which is, when agent gives you a polished answer, okay, then how would we know actually what happened in the background? And you might have come across many a times that you are working with ChatGPT and you you are looking for some answers, and then AI is deliberately giving you confidently wrong answers, right? So just to please you. So that happens, and that's the industry problem. That's not something which you you may only find. So that is the industry level problem. Now, over here in our case, imagine a customer says, "Where is my, my order? Let's say any number has been arrived as damaged." Then system returns a basically confident response saying that a support ticket has been created. The API returns successfully. The textbook looks correct basically, but the agent retrieve the right order or not? Did it classify the request to an operational team, whether it's an issue rather than a normal stats lookup? Did basically, it really execute the ticketing tool or not? How would you come to know? How would you come to know the tool has been successfully executed or called? Is the final answer is the actual tool result, or did the model it's just claiming it? Okay, so there are so many questions which you need to know before trusting your AI, and most of the times that happens. That happens, and it fails silently without without it even updating you itself, or any of the person who is using it. So that is shit, and that happens. So now this is not basically a product comparison, but it is something a tool is claiming that it is doing it, but who is going to catch that? So that's where traces come into the picture. And over here in our repository, we are going to add a small layer. The whole idea is to, keep it small, keep it operational without uploading a lot of jargons, without putting a lot of tools. The whole idea is to keep it very simple and very much clear to use. Okay, the central mental model is make the execution path of this solution very much visible, so that we can measure it, we can judge it, and we can convert the failures into the test basically. So now I'll come to this particular point, that what happens is, when people say that they want to test AI as well, so using a tool, let's say Ragas, or for any other tool which people talk about, they just explain it, but the internal process is, first you trace everything. Okay, first you build and then you start tracing that. So nobody talks about that. Ragas we need to use, but how to apply ragas? So for that you need to collect the data to use those tools, right? So over here we are just so I'm here just to establish what is the problem in this case. The uh, the the implementation is our next step, which we are going to go ahead upon. Okay, now over here basically there are four parts to this particular story. Okay, first is agents are going to break the old assumptions. The convention service usually exposes a failed request through the exception or error code. The second one is tracing for the agent. Tracing gives us the exact vocabulary that for reconstruction of the execution which have happened. These concepts are not new, and traces span come from distributed system. So I don't know how much you know about the distributed systems, whether you worked it or not, but I'm going to tell you the brief history of from where it has came, and how it is going basically. So all tracing of the systems started from the distributed system. So it is not too far, like 2010 somewhere the ideal traces were came into the existence, and I'll show you some of them research papers around that, how it came into the existence and all. But yeah, the whole idea is this is not something new which you are doing, and this is not so old as it. This is a relatively balanced concept for distributed systems. Okay, now what is new information carried out by agent traces? Retrieve evidence, prompt and responses where appropriate or not, tool selection, tool arguments, state transition, token usage, quality signals. So everything is going to fall under this. The third thing is we will look at the repository, and every call to our order support engine which we have created, there is an execution agent which is called as agent execution as a class in our. Okay, last block is not clearly visible. Yeah, I'm trying my best. This is let me know. I'll just fix it. Let me know once if it is visible clearly. Okay. Okay. So this is, for some reason, this software today is giving me hard time. So yeah, I'll share this presentation by the way, and I'm just walking through you around the notes as well. I'll minimize a bit more so that it's clearly visible on the UI. Okay, yeah, I think now the entire presentation is within the UI itself. Okay, and sorry for that. I'll make sure that there are no tool nonsense in between. Okay, so now the third item is we are going to look at the repository level, which is, as I said, we are going to call the agent execution. Each meaningful operation creates an execution step. So each and every operation you do with your agent, whatever you talk to your agent, will be an execution step, and which is going to get logged in a JSON file. As simple as that. We are, as I said, we are not implementing um, the open telemetry or lang fuse or that kind of a concept for now, because I want this to be free, open source, and everything very much doable in terms of understanding, and that's where the tools are not introduced. Okay, so I'll just go to the next slide where over here I'm going to talk about like where exactly is an agent fail, which and it most of the times fails convincingly. You will never understand it is failing. Okay, most of the times in agentic systems, if you have worked, then it will never going to tell you how it failed and where it failed. So basically, this is these are the points, exact points where this is going to fail, and it is going to convince you that it is pass actually somehow. So retrieval can fail, and then routing can fail, tool use, and the quality. Now, retrieval in terms of the vector search may return a wrong policy. Completely possible, 100% possible. It because retrieval is only as powerful as your embedding model. So there are high chances that if you use a low quality, like in this case, we are using the ChromaDB as well, which is again for demo purpose, it's good, but it is not a production ready one, I would say. For that, if you are using the OpenAI one, it is far better than the ChromaDB part. But yeah, it depends on budget. It depends on how we are aligned, what we have, what much we know, and what is the infrastructure we have. So that is the infrastructure is the major part over there to decide what retrieval and what kind of a vector database, what kind of embedding model which we are going to use. So that is a single point of failure, and which is, by the way, this is the most common failure in AI agents. Routing. Now this is something again important in the multi-agent systems, or at the same time tool callings as well. So if it's single agent as well, then it fails during the routing, where it goes to the tool calls, and it eventually, you know uh, the agent or the LLM has to decide basically that what the order ID it is asking for, and creating a support ticket or not for that. So whether this has gone really well during this routing, it has clearly asked the right tool or not. Then the basically tool use. This is the third part where model may select the incorrect tool. Now there might be argument that um, okay, I mean, how many tools to keep in an agent then? Okay, because tool use may go wrong. So ideally, like there are, if an agent is there, then probably 14 to 15 tool is the optimum number of tools you can give to an agent, not beyond that. If you need beyond that, that means you need to revisit your architecture, and you need to create something which helps you to keep that particular number. Now, how it fails basically, let's say that there are two tools, read file and read folder. Okay, in that case, these are two tools, and you passed, not you, the agent decided to pass a path, and the path was not complete. Let's say for some reason it was incorrect, and then it was still a folder, not a file. Then there are high chances that it is going to call the folder use tool. In this case, you needed to have a file, and but then yeah, so that's how it is going to fail for you. Now this quality, this may be the last building block over here is the quality. This fails without any infrastructure error. The answer may be grammatically correct, but operationally it may not be grounded. It may not be source of truth, right source of truth. Okay, so over here we are going to build traces to capture the how the tool is responding. In this case, in maybe in the bigger world or production ready world, you may want to add more to these traces, but here we are going to simply call the traces not to capture the chain of thought process from the LLM itself, but we are just going to capture the tool calls, which is and all these calls, which is routing and all this is happening inside it. Yeah, so I'll simply go next. And now since um, you have a basic idea of where the things may go wrong. Now I'm going to touch base a little bit on the history of the particular this traces, because most of the times people talk about observability but they have no idea from where it came and how it is going on. Just to understand why it is needed, we need to understand how it came into the existence as well. So for that, I have um, a bunch of research papers which I definitely want you to understand and read if time permits. But then that's okay even if you don't read it, but just get an understanding. Just summarize with LLM, and it will give you more information than anything else. Okay. Now the traces came again. Google is something which just does this kind of stuff only. Okay, so this paper called Dapper, they started, as I said, this came from the distributed systems tracing infrastructure. So the major problem was they were not able to understand how the distributed system is working. They never knew that what is happening under the inside it. What you need to do is you need to stop, go there to understand in a distributed system that what exactly is happening. So people who have worked on distributed system might know that how it works basically now and how it used to work on that uh, later. I mean, in the past. So this in 2010, these research papers come up with, as I said, this is from Google. So by the way, interestingly, this paper was researched by Google and was never implemented. Just like any other paper in Google, most of the times there are good papers, they don't implement it, but somebody else do it for with those papers. And just like Transformer, right? I told you last time, the paper was from Google, but then OpenAI implemented it. And similar to this Dapper, they showcase this paper and they showcase the work, but they never implemented this. Okay, so that's how basically this paper came into the existence. And yeah, for sure, just give it a look. As this is not that important, but just to get your, if you want to go in more deeper understanding of it. Okay, and then this is how it progressed. So Zip during that time as well, the systems like Zipkin and Jaeger made the distributed tracing outside Google as well. So building upon these papers, many other companies started implementing those Dapper-like thingies into their world. So Zipkin and Jaeger was the next one big distributed tracing kind of frameworks outside the Google part. And open tracing and open census offered basically the competing approaches as well. Now everything then was the learnings were used by open telemetry, and we know now how powerful is open telemetry, which again we are not implementing, just because it it will ask a little bit of more infrastructure from you. So that's the reason I'm just keeping it simple in this case, so that people with no infrastructure can also go ahead and don't this doesn't stop them. Now as the time progressed, when the LLM came into the existence, there were new traces. Like earlier what used to have happen is, um, trace definition was very simple. You know something, okay, you need to understand something and you need to log something. It was very clear definition. Now what have happened is, with LLM it became more complex. The gap became more complex over here, and that's where, to address that gap, now what could be the gap, right? The gap is basically, there are additional steps because LLMs are autonomous, so they might be in a position to, you know um, the LLMs are autonomous, so there are multiple steps which come into the existence, more like tool call, and uh, as I said, the routing part, all those things which the world has never seen previously came into the existence, and that's where the birth of observability 2.0 happened. Prior to LLMs, that was there was only simply observability. Now this is observability 2.0. So when everybody talks about observability 2.0, that is directly linked to the way machines have become intelligent, and that's where this has started coming into the existence. And from the LLM per se, then the agentic part came. So new layers are getting added to the whole particular system, and that's where this is getting more attraction, and this is now called as observability 2. I'll share the research paper links with you, um, just to showcase this is the convention part, which is most of the people are implementing while implementing the traces thingy. So this is a good repository. If you have time and if you are interested in learning more around that part, then do visit there. And these are some of the um, platforms like Langsmith, which is going to help you implement the similar traceability, but you need to pay them and all those things. And then this is called as Langfuse. ML Flow, obviously you might have heard about it, and Arise AI. Arise AI, and these platforms are not simply for tracing, but these are going to give you a lot of better information beyond the LLM itself or the tracing itself. Okay, so coming back to our presentation now, basically the the agents are going to understand or agents need the fourth layer as well, which is called as the evaluation signal. Now basically what happened, where that is going to be captured by traces, then we have the structured logs as well, like decision points where there's a selected action, a parameter to a method, a tool result or a tool call, etc., and then the metrics, how much time it took, whether the output was correct or not, and what is the success rate, so on and so forth. So you need every bit of understanding, internal understanding of the agent, and that's how these metrics has to be there. The evaluation part, which now I said already this, that when people say we want to use tools like ragas, right? So it is not simply you can go and apply that to your agent and it will give you very good results. So not that. In evaluation of the model or the agent, you need to have exactly the information, the data which it carries, just to go through and understand and apply testing part on your agent basically. Now this is a simple definition of that how this particular session in our coding works. So there's a clear map on in our coding versus the way we are coding it and how it defines basically. So trace height, now that it is something that happened during the execution of agent run. So for that, we have agent execution class, and this class has a method called as ask. So this method is going to log everything for our trace, and then span is something one time unit of work out inside the trace. So any work in a single trace is a span. So maybe, for example, calling and executing a tool can have three steps. So those three steps are three spans in a way. And then we store through the execution step like normal input, output, error, latency, etc. Then generation. The LLM call span with prompts, completion, token, and model parameter cost, etc. This is we are not fully capturing. As I said, I want this to be people have a real world implementation. So if you add a lot of stuff over there, then you may need some infrastructure and some of the softwares which may cost you, and that's why I'm not doing this generation part in particularly, not fully, but we have some portion of it. And then session basically, so every user conversation is one session. It has associated session ID, and without that session ID, ask is does not you know uh, it does not give a pass or fails way, but it it is without a session ID, it is incomplete, right? And then we have not implemented the evaluation part here, so I'll just simply skip this part for now. We are going to do this later. And how this works internally, architecturally, the user queries, the order support engine, and the provider is going to call the retrieval, and it is going to call the tool, whichever it needs, and then final answer. In this case, we have Ollama model. You can either go with OpenAI path as well, because the application gives us the power of doing that. And then it is tool path. So basically, only create support ticket which is in currently tool registry when it is simply asked. Okay. Otherwise, and also like as I told you last time as well, you must keep a tool registry always. If you are um, if you are not keeping that tool registry, so your LLM may fail miserably and you may not know that what it is doing internally. So you need to put a hard bound on which tool your LLM must go on. Okay. So now the next part I'm going to showcase you through live demo itself, which is already covered in this slide. But so now this is our tool which is already up and running. There was one issue, as I said, which I have fixed already. Now in this case, I will simply I'll just touch base through once it, so that everybody is up and running on that. seed.kb file is going to understand all our data which is available in this particular directory, which is called as data, and which has the FAQ MD and orders MD, return policy, shipping details, etc. Okay, so now when you run this seed.kb, this is going to convert all this data which is under the data folder. Memory part, no, I have not implemented memory part because, again, as I said, the whole idea is to keep the skeleton intentionally small. If I put it on more layers, then memory part will add later. And the idea is to keep it simple enough so that everybody who have not created an particular agent in real world may not miss out on, you know, the basic understanding. Otherwise, I mean, it's all the if all the features are there, then people are most of the time lost in features only, and the whole idea is get diluted, and that's the reason memory is so far not added through this particular thingy. We are going to add that um, later sessions. So I'm going to run this seed.kb file. What it is going to do is it is going to create a vector store. In this case, we are using ChromaDB, which is local, free, and works very well with Ollama as well if you are using with the open source tool. So I'm going to do that. Now, in case you might have already this ChromaDB vector store updated, just refresh it, because at times these are free tools and very low end tools, so it's a good habit if you just do it once again. Okay. um, so now it has index 14 documents, you know this, and it has deleted the existing collection, which, by the way, I explained in seed.kb file last time that how it works internally. And then we have this particular implementation. I'll just clear my terminal and I'll simply start app.py file. Okay, so we'll give a minute to start, and now I'm going to showcase you that how basically this is tracing things, and then I'll show you how it is implemented. Okay, so we can ask a simple question, check the order with order ID. We'll take one order ID from our orders, let's say ORD 1001. I'll just simply put it here, and the way, like, if you are using, again, I'll just repeat, if you're using OpenAI and all this, it runs more faster because you're using the API version. Here in this case, I'm using my local Ollama model, so it depends on which model you have and all those things. So according to the knowledge base, it is saying that it is shipped and the status, so on and so forth. Would you like me to, okay. So let's say I will ask that I have received a damaged or product. So ideally it should create, it should tell me to create that, okay, this is something which, yeah. So it is saying that we have created a ticket against your damaged item. Okay, so it's working fine as far as we understand from the results. But now let's do a bit of understanding that how it is working internally. So okay, so this is now in traces folder. It is going to create the traces for you, and let's see and let's understand which is the latest trace it has created. So just now it created two traces. This particular ending with B9, and yeah, so this is incorrect order itself. I thought I'll just check it. Yeah, so if you can see, our solution is now implementing this particular trace with this trace ID. Session ID is null. As I said, I mean, I'm not covering creating a lot of tool level information as well. So in some cases, it is not implemented yet, but otherwise it is going to store all the information, that which model it called, and I have what is the user input, what is the status, and then when it is started, when it is ended. So it is going to give us the exact latency in milliseconds and what is the final answer. Okay. And so on and so forth. So a bunch of information when you are talking to your agent. Now this is going to give us exact information now. The whole idea is to collect those traces and then analyze later. Okay. When you have good enough data to analyze, then this becomes, we'll do the error analysis part as well. If you know that why something is happening and why it is failing on, or where it is exactly failing all the times, just to understand what we need to fix instead of just randomly guessing what is the error. Now with this traces, you have all the information available about your um, system, that what it is doing, why it is doing, and where it is doing, okay, things. So now let's fail it once and then we'll see the trace as well. Okay, for now I'll simply exit, let's say that, because my this thing, I got the answer, it's working fine. Okay, now let's play around with it and we will ask it something which is not part of our data set. Let's see how it responds, and then we will have a trace. How are you? How are you? I need info around. Let's see which order we don't have. So let's assume that we'll take this, and I'm sure I'll modify to some. I'm sure this is not, we don't have in system, so I'll just simply call it, and you can see it is creating the trace now. No, so it is suggesting us. So are you looking for this particular order ID? No. So I can simply say my order is, yeah. So it has basically saved the traces, and again it is asking us the order ID, because it ideally should say that this order is not with us or something. You did something wrong over there, but it is still giving me answers. Not giving me answer, but stopping the conversation, which is okay, which is not a issue. But but it should tell us ideally that this is not an order which, or not the way we have the order numbers itself. Okay, so I've given another order number. Let's see, I could not find order. So in this case, it is giving us the right answer. So, so in a way, it's working fine, but still, in at times you may see that how it and why it is failing. Then you have these traces now. Now this is we we have made the basics of the observability 2.0. In this case, we are storing everything, tool calls and tool names. Okay, everything. So that's how this database of traces should go in a position, where you have enough data available, which is going to talk to your, which is later going to talk to the systems to understand where and how exactly the failures are happening. Now, when you collate this data and when you have some failures, let's say like you got 10 failures. Now you can put those 10 failures in three buckets. Let's say one bucket is failing because of tool call. Let's say the second bucket is failing because of um, incorrect prompt or something. But when you have those 3 to 4 buckets and you know now where exactly I need to fix what, and that's where the evaluation part comes into the picture at later stage. Okay, so practically this is the only part I wanted to show you from execution perspective, but then I'll simply walk you through how the implementation of this is in this particular code base. So this is again a simple Python file. We're calling it as agent execution. It is again a data class. So if you don't know about data class, then mm, I have explained this already. Just to simplify it, a data class should have all the clear-cut definitions out there, because Python may interpret integer and string and any other variable through single variable as well. It can do that. So we, with data classes, we hard push that, okay, no, this has to follow this particular type of schema. Okay, and then we have bunch of methods which are going to store all the information. Now what we are capturing is available over here. In this case, you can add more information whatever you want with respect to your implementation, and you can take out some of the information. Now this is the very basic things I have added over here, but go on, feel free to play around with this. You can put some of the things which you still find that okay are missing in this particular implementation, so please feel free to add. Okay, now the finish method is there, which is just to capture the time and the latency and all those stuff. So a start of the trace and the end of the trace. And then this particular agent execution class, which is exactly will sit on top of the app.py file. Now all these methods will be directly stitched to app.py file. Again, agent execution class is also storing some of the information that user input provider. Now again, by the virtue of this, we are collecting all the data through this particular single Python file as well. And then again, as I said, I mean, over here as well, you can add whatever information you want your agent to be traced, in terms of anything like be time or any information in terms of what is the metadata prompt, is there any system prompt, and there could be like when the tool call is happening, what all the methods you are you know analyzing before concluding which tool to call. So you can go n number of, you can print n number of information with this and store, but then you need to store in such a way that you can retrieve it at the end. And that's where the companies like Fuse and all, they simply have created those dashboards, that those schema level implementations already, where it will going to sit, and you simply need to pay for that. Okay, now this is a simple implementation, simple Python implementation, where we are just storing the information and that's it. We are not doing anything which is fancy. And then at the end, there's a save method which is going to create a trace file with an arbitrary number, or maybe you can change the number as you want. This is a timestamp which is trying to add through JSON, and yeah, and there are a bit changes when which are in app.py file. And over here, if you see the agent execution, so it's just a wrapper around what we implemented last time. So it is going to call these particular methods which is asked in our agent execution, and the agent execution is going to store all the information. And now you can implement this at every stage in app.py file, or maybe create a simple function uh, which wherever you want to call it, you simply call it, and and that's how it is going to store all the information, which is exactly this app.py file is doing for us, which is our agentic file in this case. Okay, so this is a very simple implementation, and that's why I said I'm going to deliberately keep it small so that people can catch up on this and have the traces ready by end of this particular session. Jumping back to our presentation. Okay, now I have explained you like practically what we did and what we, what we have not done deliberately, and what is the what are could be the next steps, potential next steps on this. So these slides are just simply going to walk you through around what we just now did and how this particular thingy works. Okay, so if you, let's say, this read like this, that execution step, it's where the debugging starts basically, and you have um, all the information, which operation happened over there, what was the input, and what output it produced, so on and so forth. Now a little bit uh, stepping back to the traces part. Now, for now, you may not understand how important are traces, but when you actually do an evaluation around your system and you want to put guardrails around system, these are exactly going to help you. As I said, I'll just reiterate that you find 10 issues, but you can say those 10 issues you can simply put in three buckets, maybe a tool call, maybe a prompt update. Now it will give you exactly information that where and what needs to be updated. Okay, and once you have that information in place, then definitely your agent becomes far better than what it was earlier. Okay, so yeah, tool execution is very critical here, which is most of the time a side effect which fails, very silently, and you will most of the time will not notice it, because in this case, let's say that although our agent was working fine, but let's say that you will do something that my item is arrived damaged, right? Here we don't have a ticketing system, but in real world, let's say you have a ticketing system where your order ID and a ticket number would be associated, right? Just think of ordering from Amazon, and you will find there's a ticket number, there's a particular database for ticket number as well. Okay, and then uh, in those real world scenarios, now a user would be simply happy that by listening that okay, ticket has been created, but whether it has actually been created or not, it's something which you need to validate, right? And that's where the trace will give you more information, that what have happened in between. It's just a message, or it is giving us the ticket number, but then if it is giving us ticket number and the message, and all on paper, all nothing on paper, all on just verbal communication to the user, then where exactly what is going wrong. So that way you can just revisit your traces and you can understand what is something wrong there. Now, example trace I have already showcased you practically. This is how it looks. Again, as I said, I mean, you can add more information as much as you can. You put it there with respect to the infrastructure you have at your machine, and that's the reason I'm keeping it a minimalist implementation, so that you understand and your system does not, dump you while storing such information. Okay, so traces, I already told you what it gives, and what it does not give you. Now, this is important. By tracing systems, by analyzing errors, you don't get a quality score. What you get is the information only. And that's the first step towards the quality, where you have the information available that what needs to be done. And most of the times, as I said, that the defects are in your shallow retrieval details. So how your embeddings model or any retrieval documentation was called, you will find majorly, most if you talk to people who are building agents, most of the time you will find issues over there. In retrieval they found a issue because either they need to switch the model by reading the traces, or they needed to switch the prompt itself, change the prompt, or create a template around the prompt, so on and so forth. Okay, so traces gives us the clear cut information, not the vibes only. Okay, so by vibes you can simply say something that has failed, but you need to have an exact definition of what and where. Okay, so now when you implement, you can choose what needs to be traced and what not, and which kind of sources you need to use. So maybe you're going with LangFuse, and you're going with Langsmith, you are going an open telemetry style of tracing. It's completely on your piece of budget and then how it works. Can these traces be clubbed with the application? That happens, Ishan, mostly. So these are going to sit along with the logs itself, to so that just not, yes, that happens. And then the enforcement, yes, definitely. So recently you might have heard about the agent reinforcement, which is apart. There used to be an LLM reinforcement. Now the world is coming towards the agent reinforcement, uh, applying the reinforcement learning parts in agents as well, where these are gold mines. Okay, these are going to help create an agent just like a human works, right? So you give a rewarding model, and your agent performs well on those rewards. It is there. You are right on top. So these are like uh, traces is giving you the entire information along with application logs, definitely, that how your application is performing and where it is. In some cases, uh, people interchangeably use the words like log and traces. Okay. So now we are coming to end, but I have already spoken a lot on how the eval parts come into the existence. So we get the trace, we normalize it, we aggregate, and we evaluate, and then the do the regression part basically. So most of the times, this is the only cycle which people follow, and there could be like some small things you can add here and there, but mostly um, it is this cycle which we are also going to follow. If we continue on this series, then we are going to normalize and aggregate all our traces, and then we evaluate at the end, and then we create a golden source for our regression agentic testing, which now here at the last stage, tools like Ragas, tools like Discard, tools like Deep Eval comes into the existence, because they simply call your agent an LLM with a bunch of data, which they feel that okay, this is the context of the agent or RAG or something, and they create some sort of data using an LLM and they apply. They do a brute force testing. Okay, but this I would say the last step of testing, because they don't have the golden source of evaluation. What exactly is the failure, where we need to fix, and how the test cases may look like. Now this is the last step where people use tools like Ragas, but unfortunately people teach Ragas saying that okay, this is the testing tool, which is true by definition, but not exactly true. People most of the time going to skip the part of mentioning that how we should use tools like Ragas. Okay, so for that there's a whole cycle. You need to understand your agent, you need to normalize it, you need to get do a error analysis where it is failing, then on top of it you evaluate, and from that evaluation now you have enough data to create test cases on top of it. Okay, so that's how then you feed those test cases to an LLM and call it LLM as a judge kind of a thingy, which is a very last step. But most of the times people simply start with that, which is completely incorrect. Yeah, so the next slides I have like already explained you while showcasing and spoken at least couple of times just to make sure you have enough information. Now, you may say that what are the gaps in traces? There are a lot of gaps as well because the agent conventions, everybody can write their convention. Okay, there are no standards. For example, when we were writing about, let's say, Python program, you have some conventions around programming which you follow, right? But agent conventions are still not normalized, still not um, there is nobody who can simply say that this is the correct thing for your agent. You should follow this. Obviously, there are some standardization, but not all. So this is something still evolving. So there are no conventions. MCP level tracing again. I mean, tool call via MCP create a common boundary, but then these telemetry and all those thingies are still trying to understand. They are still not have settled that how the MCP level tracing should happen on top of agent. See, this is why this is so, because this is so dynamic. You first have an LLM which gives you answer and you don't know why it is giving me this answer. Then there is a agentic system came into the existence. Now you have more complexity. Then you have another layer of MCP and all. There's another complexity. So that's where this has not settled, to be honest. Whatever you do is um, is right, but you need to do this for sure in while implementing your traces. Now, data model economics. So, the high span agents runs race cost and storage questions. So you again don't know that if you're using a bigger model, then it is going to how it is going to operate compared to again smaller model and all those things. So these particular things are still unsettled. We already know, but there's always a safe choice, and you need to create your own traces which are queryable. The whole idea is to query your traces, understand it, and at the end, if you can do a error analysis on top of it, then you are in a right place. Okay, may if not perfect, but at least to a place better than a neutral, better than a false place over there. Okay. um, so there is some next implementation. We will see whether we want to go ahead or not, depending upon how people are responding to the implementations. And with the first thing is they should do on their machine. If they are not doing it, then no point just building on top of things. Yeah, so this is the mental model. I'll just close this, trace it, then create the metrics, and then that is used for evaluation, regression, and ultimately it becomes a better agent. Now this is a rigorous cycle which is which should be always running. Okay, on your agent in your production systems as well. You need to capture the production log, and but the cycle remains the same. Okay, and if you want to go deeper, I have already shared you the Google papers and all the organizations who support the tracing, okay, and evaluation specs and all those things, so on and so forth. So this is all about tracing from my side. Implement it and make sure that you are able to count your agent what it is doing, the agentic AI. I have a little surprise for all of you in terms of the next read if you can do, because this is a weekend and if you have time, then this is the research paper. Go on, read it. It's a very good research paper. I have also reviewed it, and it's very well. Um, just read it. So AI assurance, comprehensive testing for enterprise AI systems. Whenever you have time, this is like there are a couple of people from Pune also involved over here. So if you read this research paper, it has um, this is a around a 32 page read which you can finish like in 3 4 hours with a good intention of navigating to all links and all. But after reading this, you will be having a different mindset of how the LLM testing and AI testing, you know, yeah, it's there are thought people from ThoughtWorks. So how the AI testing happens, and honestly, I simply you know don't call it AI testing. Okay, so this is AI testing is just not correct word, to be honest. It is uh, evaluation rather than testing. It should be reframed like that, because in testing you know the output, you have the deterministic definitions, but here you don't. So I think I still call is it's not a QA, it's not a testing, it's beyond that, and it happens at every stage. In so far in these 2 sessions, I have already told you many times, and I've showcased you as well, that there are a lot of pain points where it will fail, and it will fail miserably. So this research paper I would recommend everyone to read. It will change your mindset around testing, and it will give you enough information that uh, one blog or one article or a one YouTube video cannot give you. So this has a very good researched. I'm not sure around the implementation how you can implement, but well researched document which will give you enough information, and this can help you better prepare for your interviews as well, in terms of understanding of how the eval happens, and what all sort of problems which comes into the existence. Especially the whole world is moving towards the eval driven development loop, so they speak about that as well. Yeah, so with that, that's all I have. If any questions you have, I'm happy to stay for um, few minutes. As I said, I'll just try to finish under 60 minutes, which I did. Evaluation can be a subset of testing, though we know. Yeah, that's what I'm saying. That it is not exactly the testing. It is beyond that in terms of, because what happens is evaluation is we do on so there are two evaluations. One is a model evaluation, and one is the application evaluation, right? Most of the times. And and testing is where exactly we know what is the correct answer. But in evaluation, we are talking in numbers, how much percentage is correct and how much percentage is incorrect over there. Um, there there could be far better definitions than this, but in an evaluation, simply a prompt change can help as well, right? Which you will never know unless you try it out. And we don't have the exact if X then Y kind of a thingy. So that's why I was telling Gaurav that this is beyond testing. But yeah, I mean we can argue and debate on that for a long time. But at the end, testing is testing. Everybody has to be tested before going into the production. Okay, if not any other questions, then I think let's stop here. Uh, Please do implement these traces, and if anything else, let me know. We can always resolve your comments on queries through the QA Bash group. And thank you, Ishan Goro, for helping out on these sessions. And I hope people learn a lot from these at the end. Sure, guys. Bye for now. I'll just simply stop this. If you have any questions, please please put in the QA batch group as well. I'll try and answer everything over there as well. We won't miss anything there. Okay, guys, bye for now. Have a nice rest of the weekend.